Okay, so we've taken a rack out of the micro cleaner. It's been sitting in there for at least 2 or 3 days, and we're able to take that out really nice and easily with this this egg crate plastic top. And we can also take out the tubes that are associated with that rack. And what I've done is I've filled up this kind of polycarbonate food grade container, this bin, and this is going to be basically where we do our rinses. And so rather than rinsing each tube, we dunk the whole tray down in there to get the soap off. Now obviously there's still going to be soap left in after one rinse. And we want to discard this micro cleaner, this 2%. And we can put this 2% micro cleaner back in the micro cleaner bath. And now we're going to try to remove the soap as much as possible. So I'm just giving a little bit of space to get the water out without letting the caps fly everywhere. Okay. And the key is now to remove all the soap from the caps and the tubes before they go into acid. And unfortunately, this requires a lot of water. The savings in time we make up for by losing a little bit of water. While this is filling, I can kind of steal a little bit of water from the stream, and then I'm going to spill the soapy residue off the side so that my bath is still a freshly drawn clean tap water. Very exciting. But it's actually much quicker than doing 250 ml bottle culturing. So when we first set up shop, we were doing 250 ml bottles, and once your experiments start getting complicated, you simply can't keep up. You're always acid washing stuff and using the filter counter. So now we use 28 ml vials. We use the fluorometer and the filter counter only occasionally, and microscope as well, but the fluorometer is our daily tool for evaluating how our plankton are doing. Okay, so now I've got my second rinse. Again, we want to make sure there's no carryover of microcleaner into the acid bath, which is coming up soon. Now one way you could do this, if you had 3 racks of tubes for each water bath that you're drawing, you could have 3 racks that are cleaning. So by the time you're done, you have, 72 tubes cleaned from one cleaning session. In this case I'm just doing one, so I'm kind of using a lot of water per rack, but that's how it is. You can delete that part, that doesn't make any sense. Okay, so I'm giving a third rinse to the tubes, and whether you want to do 3 or 5 rinses is kind of a judgment call. If you see any soap left in the bath after a rinse, you should probably do another rinse, so you know that the tubes and caps that are going to acid are entirely soap-free. Oh, so I'm making a bit of a mess. You see I got water all over the place, and that's not a huge deal. But it is important. We have metal cabinets in this lab. It's important that you dry up that water, because what happens sometimes is the water will fall inside the hinges of the cabinets, and eventually it'll rust. And we don't want to have any rust issues in the lab. So it's important, especially after you're done, to kind of go around, open up all the cabinets, and make sure you don't have pools of water sitting inside. Okay, so now we have our third draw of water. Submersing the tubes. Okay, I see a little bit of soap. I'm going to do a fourth. And the fourth one should be good. course, in Southern California, this would have to be modified extensively because water is a bit more limiting there than here. Okay, barely not enough. So there we go. Okay, completely free of microcleaner and just traces of tap water remain on the vials and the caps. And so next we'll move over to our fume hood where we have a one normal HCl bath. It's trace metal grade, which is different than reagent grade. It's also different than quartz distilled grade. So there's 3 grades of acid in the lab. Quartz distilled is hundreds of dollars a liter, so we don't use that for cleaning glassware. We use trace metal grade HCl. Okay, so now I'm going to move over here. Okay, so clearly it looks like people have been using this bath for other items, which is okay. But you may want to, when you're in high throughput mode of cultures, you may just want to use this for cultureware. There should be one of these crates already in here, basically that travel with this rack of tubes. There's not one in there right now. I'm not exactly sure why, but there should be. So I'm hoping that we have one in the clean lab that we know is clean, we can take it out and use it. So here I am submersing this just like we did in the micro cleaner. Okay? And I'm going to leave that right on top, right there. And you'll notice when I put that in the acid bath that there was that the air bubbles ejected some acid from the bath. So it's important to clean those up right away because the acid will rust anything that it contacts, and when the acid evaporates and gets in the lab, it'll also rust any metal. So I'm just going to give that a wipe. There was a metal sash when this hood was installed, and I put some acid-resistant plastic on this to prevent it from rusting up. But underneath here, there's some parts of the metal that I can't possibly coat with this plastic. In any case, I have my rack of tubes in there. They should sit for several days, ideally a week. If you're working with low iron requiring species, you definitely want to keep it in there for a long time. Okay, and I'm filling this up same way that I filled up the other one with micro cleaner, trying to get all the air bubbles out as much as possible. Then I seal it and I put it next to the rack that it should travel with. Okay, I'm going to tune out for a second and look for another one of these grates in the clean lab, and I'll be back in a second.